first derivative at 0 equals v0. So I substitute t equals 0. Okay, hyperbolic cosine at 0 equals 1. Hyperbolic sine at 0 equals 0. So this term drops. So I get 2a1 square root zeta square minus 1 omega sub 0. Okay, this equals v sub 0. So therefore 2a1 equals v sub 0 divided by this expression. So final expression is very neat, I would say. X of t equals v sub 0, and then divided by something and multiplied by some expressions. Yeah, okay. Question was whether we are dealing with one degree of freedom system, one coordinate. Answer is yes. So we still are, I don't want to say we are stuck with one degree of freedom system. Very soon we will say adieu, goodbye, one degree of freedom system. We will go to many degree of freedom systems, and then we will hopefully get, and very soon, to infinite degree of freedom systems like beams, etc. But until now, we are dealing with one degree of freedom system. That is this classical mass that vibrates in axial direction. Okay, nothing else. So still we are there. Pay attention that we still did not exhaust that topic as an answer to the question, because we dealt with free undamped vibrations. Today we are dealing with free damped vibrations. But then there is non-free damped vibrations. So non-free, that means forced vibrations. What happens when there is a force? Still, force did not appear here. We talk about initial kicks. Say, either I took and displaced the system by some x sub 0 centimeters, or meters, or I just gave an initial velocity to this system, but nothing else. So we are still, so to say, on a very, I would say we are in the middle of this movie, which is called one degree of freedom system. Okay, because we will still have this free, forced vibrations. And when we have forced vibrations, pay attention how many things are there. Force could be harmonic. Okay, force can be some sinusoidal excitation, like something that comes, say, there is this mass and comes like this, in time. Or it could be something that develops in time as some arbitrary function. Okay, so we are still a bit far. But what I usually do is as follows. I don't like to exhaust the topic, one topic, because very often this leads to the exhaustion of the people. Now, I don't want to finish with one degree of freedom system first, because we would be finished otherwise. And we would not see the forest in the trees. We will see many trees, but not the forest. So therefore, as an answer to your question is, after a certain time, after forced vibration under harmonic excitation, we will leave this topic. Then we will go to many degrees of freedom. Many means 2 and more. Say any number. So you will say as any number you want, n. N could be 2, 3, 100, or million. And then we will leave that million degrees of freedom system. We will go to infinite degree of freedom system. Then we will come back with forced excitation under non-periodic excitation for 1 degree of freedom system. So we will visit our old friend and ask him, how are you, what is happening, and he will tell us, you know what, I'm undergoing non-harmonic excitations, what should I do? So we will provide the cure for these non-harmonic excitations. I'm just telling you what is to be expected. Okay? Then we will do main topic of, so to say, center of gravity is beams and plates or something like that, something that have infinite degrees of freedom. However, it so happens that looking into 1 degree of freedom system teaches us a lot about infinite degrees of freedom system. Interestingly, the conclusion is unbelievable. Conclusion is as follows. Beam can be reduced as infinite amount of 1 degree of freedom systems. That is mind-boggling conclusion. That you should imagine that the beam is like extremely big amount of 1 degree of freedom systems. And 1 degree of freedom systems, which we actually never see in the life. So, for example, this building is probably not 1 degree of freedom system. You don't see here mass and damping and spring or something like. Usually you don't see. If you come to my office, I will show you a mass and spring. It is. I just put it on the ceiling and I can vibrate for you so that you will see a mass, etc. Any more questions? By the way, these questions are extremely important. Why? And thank you for asking. Because otherwise, you are just going into some direction and you don't know where you are going. And as Yogi Berra said, Yogi Berra is a famous guy who has very nice quotes. He was a baseball player. He said, if you don't know where you are going, you may never get there. Okay? So, we better know where we are going. We are going towards infinite degree of freedom systems. We have infinite determination to get there. Any more questions? Any questions? By the way, please ask questions. That is very nice. Any question? Any questions?
Not right now.
After. Okay, one comment.
Can that be what made analogous to a kinematic approach, where mass is converted into a second form?
I see. Listener is asking whether this whole thing can be reduced to some kinematic approach where mass is a single point. So actually the masses that we are dealing with is a single point. This mass, look, this mass is a single. If it was not a single point, then this mass would have, like yourselves or myself, we have not only we have translatory motion, but we have rotary motions in various directions, etc. We don't have any rotary motions here for this mass. That means that what we did is unimaginable. We did something, that humans cannot do. We took this big mass and squeezed it into one point. And we deal with this one point. Why do we do that? It's very strange. We are doing it, it does not make sense to do that. Why would, mass is a mass is a mass. A building is a mass. Why do I have to reduce it to one point? It turns out that this doing makes sense. Later we will see. When I deal with the beam, then beam turns out to be infinite collection of these things. Had it not been like that, then doing this would be total waste of time. If this consideration of point mass was unimportant, so it would not be reducible to this case, complex case. So what we are doing would be total, intellectual exercise, just doing nothing, just doing because you are paid, but you don't think about that, etc. There is this joke, I think, someone goes to some eastern country, and there he sees that one person is digging the hole, and the other person is filling this hole with, with dirt. So the one that was taken out of earth. So there comes person from abroad and says, what are you doing? I don't understand. One is digging the hole and the other is straightening. He said that there was a third person who should have come. That third person should have planted the tree, but he did not come. But just because he did not come, we are not going not to do our job. So one is doing this hole and the other is closing this hole. So that is what happens. So we are not, naturally, we do not want to do this. We will have these three elements. I mean, making a hole, planting, then closing. So we will do this. We would like to see the whole picture. So now we are just making the holes. Later we will plant the tree. And then we will also straighten around so that everything looks nice and dandy. Any questions about where we are going? Okay, now that we know where we are going, we will go there. So, do you have any comments? I mean, let us say as follows. Imagine that you are a member of a company, and in that company you got this expression. And the boss says to the people, the owner of the company says, I would like you to excite me with this formula, and for this excitation, I'll pay 10% more salary. It's not a bad proposition. There is some formula on the blackboard. And someone says, bonus of 10% of the salary. I mean, every month, starting from today, every month forever, once you are working, you will get bonus of 10%. But excite me with this formula. Say something profound about it. Okay, we start with person in the corner, Mr. Dale. Something excitable. If you are not ready, then think. Whoever wants to start. Yes, please. You are asking a question or commenting? Do you want a bonus or you are asking a question about the bonus?
No, I'll observe it to be the product of an exponential function, decaying function, and as well as a hyperbolic.
Yes, listener says that this is a decaying exponential function and hyperbolic function. Product.
And I noticed there's also an amplitude, which is a coefficient up front.
And there is a coefficient. So why is this excitable?
I guess it can be examined in terms of derivative.
Okay, listener says that the fact that this formula is right could be examined. We can calculate the derivative and check the derivative in the beginning equals v sub 0. That naturally, this formula is correct. So therefore, the first derivative will be v sub 0. There is no doubt about that. Any other comments?
What can we explain from this one? What can we explain from this one?
I'm asking you, what you can say something interesting about this formula.
I have no idea.
Okay, but think. You may not, student says that he has no idea. That is okay. That is fine that you have no idea. But maybe you can think a minute, and maybe then you will get an idea to say. That is normal not to have an idea in the beginning. But please think. Maybe someone else has. Yes, Mr. Dale.
Omega sub 0 shows up in the decaying harmonic function, or the decaying function, the harmonic function, and the function itself is inversely proportional to omega sub 0. So as omega sub 0 grows.
Okay, listener says that the fact that omega sub 0 is here
It's in all three of them.
is an important fact because what is omega sub 0? It's square root of k over m. Yeah, natural frequency. So what he says is when k is increasing, then x of t will be decreasing even more, something like that. And analogous fact is here, so to say. So that is interesting. What else? You have 10% bonus. And first person also has 10%. And the person who has no idea also has a 10%. I'm a very rich company CEO. What else? Please, as the rest of the participants, please get your 10%.
Let's see if I follow.
Yes?
This is the case where zeta is greater than 0 but less than 1.
No, here zeta is greater than 1.
Greater than 1?
Here zeta is greater than 1.
Okay.
That is overdamped case. Therefore, there is no harmonic functions, no sines and cosines, okay? So because that is overdamped, there's a big damping. Very fast this goes to 0.
So is it correct to think that it will, the decaying part will decay quicker?
Yes, naturally, yes, listener says that this function naturally decays much quicker if zeta would not have been bigger than 1, but would be smaller than 1. Yes, you have this 10% increase. What else? Who else? Yes?
This is where zeta is greater than 1, so it seems weird that in the coefficient, you end up with I in the base, or in the denominator.
No, zeta is greater than 1, so therefore this is real, and this is also real.
Oh, yeah.
Zeta is greater than 1, so it's okay. There's no surprises. Any, yes, Mr. Dale?
The exponential function, even though it includes the natural frequency, if your zeta is still c divided by 2m omega.
Well, that
sub
means
zero,
still. That is what we did not change it.
well, then you can remove that from the exponential. So your decaying from the exponential is actually independent of the natural frequency.
Yes, we did. That is correct. So, because if I substitute the values of zeta and omega sub 0, etc., then omega sub 0 will disappear. Yes, that is correct.
Question.
Yes?
This one depends on just only the second term e power 2 minus theta over omega 0 t. That's it, right?
Yeah, it depends on this, and pay attention of this also.
Psi hyperbolic cannot be over than 1 because it depends on if theta is bigger than 1. That term, I mean psi hyperbolic, cannot be over than just only 1. Psi, whatever psi it is, psi hyperbolic it cannot be over
No,
than
I think
1.
that hyperbolic sign can be greater than 1.
Can be greater?
Hyperbolic sign, yes, because it is, look, e in power x minus e in power minus x divided by 2. So when x goes to infinity, e in power x goes to infinity, e in power minus x goes to 0. So this can be bigger than 1, this guy. So from that point of view, sine is not a good name for, I mean, yes, there is h here, but to start with sine is not very successful. But humans, I mean, our ancestors did not want to introduce new symbols, too many new symbols, because students, us, would not comprehend too many symbols. Okay, so this can be bigger than 1. Okay, more comments? Do you want 10%? Or you are happy with your lot? Or your wife makes so much money so you don't want to think?
Well, you have a damp system expressed in terms of natural frequency,
Yes.
which does not depend on damping or undamping.
So student says that having here omega sub 0 is fascinating. I agree with him. I think that is nice. Yes, you get this 10%. Who else? Who did not participate? Yes.
I have nothing to add. But yeah.
Okay, so but you agree with everything that was said? Yes. Okay, there was one, usually I like big classes. Why? In the big class, then because of amount of people, then students are covering every possible case. So one case you guys forgot to mention, that this V sub 0 was given in initial condition. It is like vibrations happen because of V sub 0 exists. Because if V sub 0 was 0, then the x of t would be 0. So what we have, this is a cause of everything here in this problem. And that is an effect. So therefore, we can actually write this as follows. So system, this cause is v sub 0. Effect is x of t. And system is characterized actually by this one. Multiply cos by 1 zeta square minus 1 omega sub 0 in power minus zeta omega sub 0 t hyperbolic sine zeta square minus 1 omega 0 t. So indeed, system depends on zeta and omega sub 0. This 1 degree of freedom system makes that this system is actually made like this. So it's a function as we denote. So omega sub 0 is something from outside. That is the behavior, describes the system, and then we get the effect. Now, fascinating thing is that bigger the v sub 0, bigger x of t. So it's a linear relationship here. Had it been not so, we would have been surprised. You should be surprised. Come on, I increase the kick, and system would not give me bigger displacement. Suddenly, that does not sound to be okay. Okay? Homework. Yeah, maybe I will give you first yes, some figure, how this behaves. That is how it behaves. Okay, v sub 0 is 10, zeta equals 1.4. So that is how it behaves. You may want to make a figure. So maximum is at 0.5 t, 0.40. So just one figure is enough. Yes, sir?
Overdamped case, right?
Overdamped, yes. That is the system we talked about. Homework will be to consider for these two cases, for this case, I mean v equals v sub 0. Okay? A critically damped system and underdamped system, and make figures. Now figures you can make, of course, on computer. So I will write down. X of 0 equals 0, x dot of 0 equals v sub 0. Consider critically damped case, so zeta equals 1, or underdamped. Zeta is smaller than 1. So here zeta equals 1, so consider like 0.2 or 0.4 or 0.6 or 0.8 or 0.9. So choose any of numbers from here. Okay, I will write down for myself assignment 4. Zeta is smaller than 1, zeta equals 1, v sub 0, x sub 0 equals 0. Make calculations and graphs. Have a good day and have a good weekend. You may want to give your homeworks if you don't mind.